Good morning everyone, this is Dr. Mama Ghazal and today in this video we will talk about the types of colloids because in our previous video we have already completed colloids and what are the working procedures and what are the examples of colloids. Now in this video we will talk about the types of colloids and how the colloids has been divided into two classes. So those are the two classes by which we are talking about colloids. Those are said to be lyophobic or lyophilic. When we are talking about lyophobic colloids or sols, which are also said to be lyophobic colloids or lyophobic sols, they are all another name of that lyophobic or solvent fearing colloids. Solvent fearing means which are also known as sols and which are which are water haters. And when we are talking about lyophilic or solvent loving colloids, which are known as gels. So lyophobic sols are those in which the dispersed phase has no attraction for the medium or the solvent, and lyophobic colloids are invariably substances that are highly insoluble in the dispersion medium. These are usually aggregates of small molecules or in cases where a molecule is not defined such as silver chloride, and they consist of a large number of units of the formula. The examples of lyophobic sols are dispersion of gold, iron hydroxide and sulfur in water. Lyophilic sols are those in which the dispersed phase exhibit a definite affinity for the medium or the solvent, and the example of lyophilic sols are dispersion of starch, gum and protein in water. Lyophilic colloids are invariably polymeric molecules so that the colloidal solution consists of a dispersion of single molecules, and the stability of the lyophilic colloid is a consequence of the strong favorable solute-solvent interactions. Some of the characteristics of a lyophilic and lyophobic sols are, or we can say that on the basis of those lyophilic and lyophobic sols and colloids has been differentiated and divided are, one of that major property is the ease of preparation. Lyophilic sols can be obtained straight away by mixing the material such as starch or protein with a suitable solvent, and the joint molecules of the material are of colloidal size and these at once pass into the colloidal form on account of the interaction with the solvent. And lyophobic sols are not obtained by simply mixing the solid material with the solvent. So these are the examples, just like in your picture you can see an example like ferric hydroxide, which is an example of lyophobic colloid. Another property is charge on particles. Particles of hydrophilic sol may have little or no charge at all, and particles of hydrophobic sol carry positive or negative charges, which gives them stability. Stability is also another property or a characteristic of lyophilic and lyophobic colloids or sols. Lyophilic colloids are thermodynamically stable and lyophobic colloids are thermodynamically unstable. When we are talking in terms of a reversibility, so lyophilic colloids in which the precipitation in the lyophilic sol is a reversible process, and lyophilic sols are precipitated only by high concentration of the electrolytes when the sol particles are desolvated, and lyophobic sols are precipitated even by low concentration of electrolytes and the protective layer being absent. Reversibility in terms of the dispersed phase of lyophilic sols when separated by coagulation or by evaporation of the medium can be reconverted in the colloidal form just on mixing with the dispersion medium, and therefore this type of sols are designated as reversible sols. On the other hand, when we are talking about irreversible sols, so in which the lyophobic sols once precipitated cannot be reformed merely by mixing with dispersion medium. Interaction is also a very important property in the lyophilic and lyophobic colloids. There is a strong attraction force between colloids and the liquid, and in lyophobic colloids there is less or no attraction between the colloids and the liquids. Viscosity for the lyophilic sols are viscous, and as the particle size increases due to solvation and the proportion of free medium decreases. Warm solutions of the dispersed phase on cooling set to a gel, just for example preparation of a table jelly. Viscosity of a hydrophobic sol is almost the same as the dispersion medium itself. So lyophobic colloids have the same viscosity as the viscosity of its own solvent. Formation of sol, which includes lyophilic colloids, form a lyophilic sol, and phobic colloids form a phobic sol. Water as a solvent, like lyophilic colloids, when water is taken as the solvent, lyophilic colloids are known as hydrophilic colloids, and when water is taken as the solvent, then lyophobic colloids are known as hydrophobic colloids. Preparation medium is for a lyophilic colloids. A lyophilic sol can be prepared by the direct addition of a dispersion phase like colloids into dispersion medium, which will be the liquid one, and the lyophilic phobic colloids, a lyophobic sol, can be formed from special techniques such as mechanical agitation and some work by which we are mechanically grinding, mixing it together and making a lyophobic colloids. Now, this is a brief difference between the lyophilic and lyophobic sols, which we already discussed. So, for once we are talking about philic sols, it is having direct mixing with dispersion medium, no, not prepared by direct mixing, little or no charge on particles, but in a phobic, particles carry positive or negative charge. In the philic, particles generally solvated, and in phobic, no solvation of particles will take place. So the viscosity higher than the dispersion medium, which is setting for a gel, and in this lyophobic, viscosity almost the same as of medium, do not set as a gel. Precipitated by high concentration of electrolytes, and phobic are precipitated by low concentration of electrolytes. Lyophilic are reversible in nature and lyophobic are irreversible in nature. Lyophilic exhibit Tyndall effect and lyophilic do not exhibit Tyndall effect and lyophobic exhibit Tyndall effect. So on account of relatively small particle size, lyophilic sols do not scatter light and show no Tyndall effect, and lyophobic sol particles are large enough to exhibit Tyndall effect. Particles migrate to anode or cathode or not at all, and particles migrate to either anode or cathode, which is a migration in an electric field. So this is the basic conclusion, like colloids can be either lyophilic or lyophobic. Basically, lyophilic colloids are solvent loving particles and lyophobic colloids are solvent hating particles. The main difference between lyophilic colloids and lyophobic colloids is that lyophilic colloids are thermodynamically stable, whereas lyophobic colloids are unstable. So this is all about the differentiation between the lyophilic and lyophobic colloids or cells. So I am concluding this video. If you like my video, please do share, like and subscribe my channel. Bye for now.